see in it. And with that being said, I'm going to pass things on over to Andrew to start today's webinar.
Thanks so much, Sophie. Like Sophie said, this monthly well, not monthly, quarterly industrial webinar session is entitled Cutting Edge Building and Production Line Energy Management. And our presenters today will be Dave Gontars and Ben Paul Gilmore from Lockheed Martin. Next slide, please, Sophie. Just a couple of announcements here up front. The Energy Star Industrial Annual Partner Meeting will be held from the 23rd to 24th of September at Music City Center in Nashville, Tennessee. Right, and we will, as always, will be preceding AEE World, and AEE World will be taking place from the 25th to the 27th of September. Just a reminder, if you haven't registered yet and are planning to attend, please go ahead and register for the partner meeting. I really look forward to seeing you all in person. Next slide, please. This year's theme for our annual meeting will be Informed Energy Management through Better Data, Artificial Intelligence, Modeling, and more. And some of the panels you can look forward to, as you can see here, are AI and data strategy, digital twinning, as well as our top project poster presentation, decarbonization planning, and more. For a full agenda, we have sent that out recently, so please refer to the full agenda for a breakdown of all the speakers and sessions that you can expect to see at the annual meeting this year. Next slide, please. And also this year, we will be hosting 2 plant tours for industrial partners that attend the annual meeting. Brown-Forman has graciously allowed us into one of their Jack Daniels distilleries, and Nissan has also graciously allowed us to tour their Smyrna automobile assembly plant. If you haven't registered for a tour and would like to, please do so at your earliest convenience. I believe the Jack Daniels tour is completely full at this time, but there are some slots available for the Nissan tour if that's something that you are interested in. Next slide, please. And without further ado, I will turn things over to our speakers today, Dave Gontars and Ben Paul Gilmore of Lockheed Martin. Take it away, Dave.
Okay, thank you, Andrew and Sophie, and thanks to everyone that's joining us on the call here today. We're going to spend the better part of the next hour going over the energy management and control system in place at our large Fort Worth facility, the one where we make the F-35s primarily. And if you would go to the next slide, please. I'm going to be going over this presentation, I guess, from the perspective of my role, which is kind of corporate wide. I'm on the Lockheed's corporate environmental safety, health, and sustainability team, and my primary role is to go around to all our sites looking for energy saving opportunities. I'm really fortunate to be able to do that, get to see a broad range of deployments of energy management systems like the one we're going to talk about here. But I think I can safely say that the one we're going to talk about here is unlike any of the others that we have. In size and scope, what you'll see here is pretty much the best of the best as far as our company is concerned. And we're really fortunate to have Ben Paul on the call with us here to be able to share his perspective from the site. I think he's actually, the camera there is showing him in his environment, right? In the control room there. Is that right, Ben Paul?
That's the engineering office, yes.
Okay, and so we'll talk a little about that as we go through this, but really quite a story, and I'm really glad Ben Paul's able to join us here to add details to what we're going to talk about. And in fact, the slides here were generated from previous presentations that Ben Paul provided. So with that, we're going to talk about the system. We're going to talk first about the history, how it came to be, kind of what the goal of this system was and is currently, and how it's grown. You'll see it's grown way beyond just controlling temperature and humidity in some spaces. Talk about projects, some kind of traditional energy management projects that the system facilitated, along with a number of unique opportunities or unique situations that the system being in place help the site resolve. Certainly go through the best practices of the decades of time that Ben Paul's been there, along with the team. He's gathered up, you can imagine, a number of best practices that we're going to talk about, along with the issues and the challenges, right? Like anything else, and certainly anything of this size and complexity, it's not a piece of cake to get put in place. And so we'll talk about some of the hurdles and things that you could expect if you're going to kind of embark down this road, and then talk about where the system is today, some of the results that we could share as production is ramped up there at the Fort Worth facility. Talk a little about Energy Star. I think we'd be remiss if we didn't get a slide in there and talk about the site's relationship with Energy Star, as they've had a number of different engagements over the years, and then we'll wrap up. So with that, if we could go to the next slide, Sophie. Okay, so here are some more numbers, and again, just to give folks an idea of the size and scale. As I mentioned, it's I would say pretty easily the largest system that we have at any site in our portfolio. We probably have, I don't know, 5 or 6 other sites that are pretty similar in size, but surely nothing that is controlled and monitored to anywhere near the degree that the Fort Worth site is. And again, we'll talk about how it got to this point. It monitors a number of buildings there, not just the main production building that you see in the picture. It's utilized Siemens system over the years. I think they're getting ready to upgrade to the latest version, or maybe in the process of doing that as we speak. Just from a corporate standpoint, we don't have a corporate standard that we look for each site to have. It would be kind of the question has come up a couple times over the years, and the fact that we presently are made up of a number of different previous companies and who had their own standards. We have different systems of all different shapes and sizes throughout the corporation that those teams are familiar with. So we're not necessarily looking to standardize in one system or the other. We do have a number of other sites that do utilize Siemens. I'm not going to go through all the numbers, but you could see, I guess one thing notable to point out is the number of people involved kind of at the bottom of that box on the right, including a number of in-house personnel that really are the key. It's not just the systems itself, but the people that keep them running that is important. I don't know, Ben Paul, did you want to point anything else out on this slide or anything that stands out?
No, not really, other than, the 4.5 million lines of control code. We do write all of our control software in-house. We develop all of our graphical interfaces. We have about 2,400 of those that we develop in-house. All the software we do inside. We only use Siemens for basically controlled hardware and installation. Everything else is designed and installed and operated, controlled by Lockheed.
Gotcha. All right, next slide, please. Okay, so here's the background. This started over 40 years ago, and it came out of the energy crisis of the late 70s, early 80s, the 70s and 80s. For those of you who remember, I don't know how many people, I vaguely remember sitting in lines at gas stations and other things. And so that's where it got its start. You can see there's a pretty decent amount of money devoted to that back in the day. And then it kind of, when you compare the initial implementation of the numbers you saw on the previous slide, you could really get a feel for how much it's grown. As Ben Paul mentioned, it's it's really a standalone system, right, dedicated to the site there.
Correct.
And
We have our own network. We're not on Lockheed's network. This is an Air Force plant, so the Air Force paid for my network, and we operate and administrate that network.
And maybe you could talk about that last bullet there, Ben Paul, the difference between operational technology and information technology.
There's actually a huge difference, and unfortunately, building automation systems are frequently thrown into the IT group technology. Most building automation systems ride on the company's IT network. And these systems are really OT. They are operational technology. They transfer huge amounts of data continually, and they're two completely different things. That's one of the reasons why we have our own network, so that IT can't shut us down when they start having networking issues. That's why that's why the Air Force has always insisted that we have our own network that is totally isolated, and it's air gap from the real world. We can't be hacked because we can't be reached. So there are no cloud services with this system.
All right, if we go to the next slide, we'll talk a little about the goal. Now, I think what's notable here, you can see a number of different things that the system is utilized for at this point. And the thing that strikes me, without reading every one of these, certainly energy consumption or reducing energy consumption was kind of the genesis of the system being installed. And these days, or in the early days, I should say, the systems were leveraged mostly to keep temperatures and humidities where they need to be. And what stands out here is how many additional capabilities the system provides now to the site, right? And we're going to talk some more about that too. It reaches down to the manufacturing floor. It reaches outside of facilities into, helping with compliance with environmental safety and health regulations. There's just a number of different things beyond just basic monitoring and keeping systems in the right temperature and humidity areas. And at the same time too, and maybe Ben Paul can talk a little about this. The efficiency, yeah, it's great, it's efficient, but at the end of the day, as we go around the country and talk to other sites about their systems and some of the potential benefits, the benefit beyond energy savings, the enhancement of reliability, and again, keeping those critical processes running and up and running and within the tolerances that need to be maintained to make the products that the customer requires. You get kind of double your bang for your buck as you add sophistication to systems like this. I don't know if you wanted to add to that at all, Ben Paul.
Well, the system is it's very integral to the plant operations. We're controlling every aspect of infrastructure, from electrical, natural gas, water, domestic water. We also are tied together with the plant-wide fire alarm and mass notification system. We share the same Air Force-owned network because both of these systems are so security sensitive. And as far as production processes goes, over the years, the production departments have turned more and more of their complex processes, especially where multiple infrastructure systems mesh together. They've actually turned those over to us because we can control them better. Our hardware doesn't obsolete near as frequently as their little PLCs and such that they were using in the past. So we've been able to provide them with a better computer-based control system that doesn't continually need to be upgraded, and they just enjoy using it as opposed to continually having to maintain it and update it.
All right, and we're going to talk a little more about that in a couple slides here. But before we do that, if we can go to the next slide and talk a little about the growth in the system. As we mentioned, it started a little over 40 years ago. And you could see here, I mean, again, my experience has been just because you put one of these systems in, that's just one part of the of making successful use of it, right? And so once you get it in there, you got to have processes to make sure that it is leveraged wherever possible, right? And it's considered, in cradle to grave, whether we're talking about doing O&M projects around the plant, resolving anomalies, rearranging space, right? When you I'm sure a lot of us on the call, we're asked to take a, I don't know, 5,000 square foot office space and turn it into a lab or vice versa. And, if the controls folks aren't involved in that, you can start to get things, that don't jive with the overall system kind of architecture, right? And in some cases we've seen at other sites, if somebody's not kind of watching over the whole process and the project process that you see at the bottom here, you can end up doing one project and we'll have one vendor system put in, say Siemens, and then the other project has a Niagara system put in or a Johnson system put in or something. And, there's not even some consistency, and then it gets turned over and the site team, that has to maintain the site struggles to do so. So one thing that certainly stands out here at Fort Worth, again, is how Ben Paul and his team are really involved in every single aspect of what goes on at the site. And I don't know if you want to jump in here, Ben Paul, and talk a little about that.
And this is not unique to me because I've been doing it this way for 38 years, but every single project that comes into the department, whether it's a $20,000 overhead project or a $350 million capital project, every project pretty much goes through and a lot of times starts in this office during the concepting phase. We're working with the A&E firms to tell them what all they need to do in that area, if they need to upgrade things or bring it up to standards or what have you. But we're involved in the design. Once again, we do our own controls designs for the A&Es. Then we're involved in the construction process, the programming of the systems to get it ready to turn over to our plant engineering group, the commissioning of the systems, and then functional use. Once we put something in, we don't turn it over to somebody really. We stay involved as the experts on that system for its life. So we are continually involved in everything from cradle to grave.
Yeah. And my experience has been when there's somebody there that does that, you do see the results, not just with system performance, but certainly energy savings as well, right? And the second that focus and attention gets drawn away for a period of time, things start being put in manual, things start getting overridden, and you start to see it eventually in your electricity and gas bills. So again, kudos to the team there for staying on top of it. Okay, so if we go to the next slide, next slide just kind of shows some specific examples of projects. Again, what started as an energy reduction effort, you could see expands and all the capabilities that it has. It really, when you have such a robust building management system as a backbone, it opens up avenues for all sorts of different projects that maybe you didn't even think of or you didn't even know were possibilities, right? And you could see that the team there, has a wide variety of uses for the system, so much so that there was recognition, as you see there, in 2020 from the Secretary of Defense. And I'd love to hear a little more about that recognition, Ben Paul.
Well, that was a multi project that was put together. Our primary contributions was a large 2 million gallon thermal energy storage tank, rainwater harvesting, where we collect almost 10 million gallons of rainwater and condensate water off our air handlers every year to reduce water consumption, PV systems, a massive LED lighting upgrade in our factory, and factory and warehouse production areas. And, and then also just optimizing economizers across the site. People think in Texas, surely you don't use outside air. Yes, actually there is about 3 months a year where we can use a great deal of outside air, and then a couple of months where we can use some outside air. But that equates over the last 42 years to $150 million in savings just in economizers alone. So you don't ever rule out anything. Everything has to be looked at and fully utilized.
All right, thank you. And then if we go to the next slide, please. We'll spend a little time talking about sub-metering, right? And here again, we were at the site earlier this year, and we're standing in the room that Ben Paul is in right now. And when I tell you there were a lot of numbers on the wall. I mean, it's incredible the amount of data that is at the team's fingertips there, right? And I thought this little screen capture is kind of cool. And correct me if I'm wrong, Ben Paul, but it looks like you've got basically a panel schedule that is showing real-time data, right? That you can use to monitor consumption for the different components. But then I assume you could also use it if somebody comes in and says, "Oh, I want to add 100 amps to this feed or this panel. Can we do it or not?" It seems like all this data would also be helpful in those sorts of circumstances to determine whether you have to add transformers, panels, or other gear, or we can make do with what we got.
We have over $10 million invested in submetering. You can see the different kinds of meters listed. In accordance to meet EPAC 2005 and ESA 2007 for federal sites, that's what we're required to do. And this particular graphic interface shows one of our newer electrical panels. Like it says, it shows every breaker, the breaker size, the amp draw, the kW, and then it shows whether it's open, closed, or if it's normal. But you can actually select any one of those points, and it'll pull up a new graphic interface that has 20 to 30 more points that are associated just to that one breaker. So we can tell every aspect of what's going on our electrical system using this kind of technology. And then everything of any importance is trended. Like Dave says, we can tell how much capacity we have left on a panel or on a feeder or on a unit sub. And we can determine whether or not we're going to have to pull a new feeder, which is terribly expensive, or if we can expand the existing one by adding additional breakers. And that can save millions on a project, that kind of information.
Yeah, and that's the type of savings that is kind of it seems like it can be hidden sometimes, and when somebody asks, geez, is it really worth putting, or expanding the capabilities of our building management system? There are some more easily quantifiable savings costs, but then examples like that to me are great examples of the hidden benefits of again, putting the systems in, but not just, I can't emphasize enough, the system without the people is probably less than half of the benefit, right? You need them both, really. And when you get them both, sophisticated system along with the sophisticated users and operators, it kind of, sometimes it can exponentially improve the savings that you see, hidden and otherwise. All right, so I think the next slide, if we can go to the next slide, please. We're going to discuss a little about, again, we're not just monitoring some temperatures and humidities here at Fort Worth, right? We got a huge line where parts come in one end of a mile-long building and an F-35 rolls out the other. And I think we're trying to roll out over 100 a year here. And so there's a lot going on in that building. And there's a lot of opportunities to streamline and lean the manufacturing floor as well. And I'm going to step aside and let Ben Paul talk about a few of those examples in more detail. I know he touched on them earlier in the presentation. The one that stands out to me is around the paint booths and the way that he used his system to give the operators of the paint booths a clear understanding of what mode they're in and what mode they should be in, and making sure that the two jive, so that we're not wasting a lot of energy blowing air through a paint booth that maybe doesn't need as much. And so with that, Ben Paul, I'll let you explain a little further some of the things you've got going on the manufacturing floor there.
Okay, well, to talk about the first slide, the top one there, the picture, that's the F-35 final assembly line. And we have 26 final assembly stations, and they can be very energy intensive because of all the systems that feed it, whether it be PAO, vacuum, avionics cooling, hydraulics pumping, all those things combined. If you were to just turn all this stuff on and just let it go, it take a huge amount of energy. And our policy is to provide what's required when it's required for only as long as it's required. So the production actually came to me and said, okay, we got all these systems, but we don't know how to make them talk to one another. And so I actually provided them with a Modbus backbone so that they could tie all these systems together through me so that I could help them with their usage, kind of monitor what they're doing, and I can turn things off for them when they forget to and things like that, and keep the energy usage down to a minimum, and also provide them with a much more reliable computer infrastructure to control their HMI consoles with. The picture below, the paint booth, that is one of the most energy intensive processes on site, because I have to take any kind of conditioned outside air. This is 100% outside air system. It could be 14 degrees outside or 114 degrees outside, and I have to pull that air once through the mechanical equipment upstairs and deliver to that space 100 feet per minute in paint mode at 71 degrees plus or minus 1 degree at 51% RH plus or minus 2%. So these are some very, very tight tolerances that I have to take any condition outside air and convert it in order to get it to the right painting conditions for a robot. So we control every aspect of that bay. I don't control the robots, but I do talk to them, and they don't spray unless I'm okay with it. All the safeties for the EPA or the TECQ are built into our software. So if anything gets out of tolerance, the bay shuts down and it can't be restarted locally. They have to contact maintenance in order to get whatever the fault is resolved, so that we're not doing any kind of illegal painting operations. There's humidity modes, there's painting modes, there's sanding modes, and they tend to like to come up with modes that we have to develop for them. And we actually put in a little touch screen that we can reprogram for them to select their modes with. So they press one button, and then $20 million worth of mechanical hardware activates and does whatever is required in order to get that bay into the correct operating mode, paint an F-35.
Yeah, it's really cool, and I guess from my standpoint, it's cool too, because we have a real live, living, breathing example of things like that, within the company that we can point to and leverage, because we certainly have large paint booths at some of our other facilities as well, as you might imagine. So yeah, so pretty neat, kind of unique things happening there, tying the or the energy management system to the manufacturing floor. If we go to the next slide, please. That's not to say we're not forgetting about the we'll call them the blocking and tackling, more straightforward projects, right? Certainly VFDs aren't on the cutting edge anymore like they were a while back, but again, having the system in place facilitated the use of them as that concept proliferated. And you could see the sheer numbers there of the numbers of drives. And then one unique way that the team there used the VFD technology was with their computer rooms. And I'll let Ben Paul explain that a little more there. It's kind of what we've got in the middle of the slide.
Well, we provided in our data centers, we have redundant cooling, totally separate crack units with separate chill water systems, with separate power feeds, so that a system can be taken down for maintenance and not impact the computer room operations. But while these units are there and normally functional 95% of the time without any kind of interruption, we decided to put VFDs on all of our crack units so that we could run both the primary and the backup at the same time at greatly reduced speeds. And what we found was that one unit running at full speed was using 7 kW, where 2 units running at 50% speed used 2 kW. So we actually reduced every cooling row by 5 kW just by installing VFDs on our crack units. And when you multiply that by, nowadays we're up to around 200 crack units. That's significant savings right there. Half a megawatt. Or that is a megawatt of reduction in demand and consumption. So it was a powerful thing to do. And these VFDs for these simple low horsepower motors only cost about $700 a piece. So it wasn't a very expensive modification to go do that.
Well, and then another benefit too is you basically have running redundants, right? So if one of the units trips off for any reason, the other one's already, it's not starting from nothing, right? It's just the others ramp up to meet the need.
That's true. They
So,
continually monitor one another, and if one goes
Yep.
down, the other one automatically increases to its design speed.
Yep. And I know we've done that with you know, pumps and like central chilled water plants and other things. I know one time I remember we renovated a chiller plant, and I took the operators down and I was like, no, we got to turn that second pump on. And they're like, come on, that doesn't make any sense. And then we actually turned 2 on and noted the KW versus having the one running at full speed. And you know, it's pretty again kind of cool to see that in action. Okay, so again, these are kind of blocking and tackling, and then manufacturing. The manufacturing floor was certainly more unique. The next slide is really unique, and it kind of addresses something that you can't even really plan for sometimes, right? There's some things, if we go to the next slide, that just come up, and you know, we've had a couple of them here even since 2020, right? Between COVID. Certainly in the pandemic, and then the winter storm there down in Texas. And so, again, I'm going to turn it over to you, Ben Paul, and you could talk a little about these two unique events.
Well, when the pandemic hit, you know, ASHRAE was coming out with what do we need to do in order to mitigate the issue, and they instantly wanted to increase the outside airflow into office spaces, lab spaces, factory spaces, and they were trying to figure out, well, how do we accomplish this? And it was really throwing a monkey wrench into everybody's energy conservation, because you know, if you're in Texas in the summer, you don't want to introduce a whole lot of outside air. So how do you go about doing this? And everybody was, you know, cussing and discussing how to accomplish the goal. And once I saw what they were trying to do, I actually programmed my entire plant to do this in 6 hours, and I commissioned it in 2. So in an 8-hour day, I was done while everybody else was discussing it, what to do. That's the capability. You know, we use a thing called structured programming technique, and because of how we program all of our systems, it was very simple for me to go in and make the modification that was required, and it's all tied to a switch, so that I can activate it or deactivate it whenever I want or whenever it's needed. So if we got into a peak demand situation where we just couldn't afford to bring in this outside air, I could turn it off for 30 minutes and then turn it back on, whatever was required. Similarly, we had this winter storm Uri where it got down to 0 degrees for almost 7 days out here, which is just horrible for our conditions. Our plants just aren't designed for that. And electricity, we got into real-time pricing, and we also got into penalty pricing, where we were paying an astronomical amount per megawatt hour. We normally pay like $30 to $40 a megawatt hour, and our prices were getting up to around $8,000 a megawatt hour. So we were able to use the system because we had very limited personnel on site to do anything. So because everything is so automated, we were able to make a lot of very quick changes to get our demand down, and we were able to avoid charges of over $7 million by being able to do this. And you know, this was changes that had to be done quickly within hours in order to not incur these costs.
All right, thank you. And if we go to the next slide, I'm just going to briefly touch on this. This is kind of, you know, some of the next steps that the site team is taking. You know, we've seen at a number of our sites the desire, and in some cases that the projects have followed on to put the data analytics packages over top of the existing building management system. And Ben Paul and the team there at Fort Worth has kind of handled this a little differently, in that, again, kind of similar to what we were talking about in the last slide. You know, the fact that the team is there, they know the system, and they've begun to leverage the system to do these sorts of kind of, I'll call them next level tasks that some of these analytics packages are providing, and you can kind of see the progress there, along with some of the things they're looking at for the future. Anything you want to say here, Ben Paul?
Well, we actually started doing this in 2007 when we built those first aircraft paint bays because the systems were so complicated. There was no way one of our normal day-to-day operators could take a look at hundreds of points on a graphic and decide, oh, that's the problem right there. So we realized we had to help. We had to come up with some kind of fault detection and be able to tell them what's wrong when there is a problem. And we expanded upon that and applied it to our 700 or so air handlers and units across the site so that we would have fault detection on all of our hardware. And because we're off the network, we can't use any of this cloud-based software, any of this third-party software to do this. So we basically had to develop our own, and it works very well for us. Our maintenance department likes it, and it accomplishes the objective.
Great. All right. Well, thank you. And so now what I want to do, or what we're going to do here is pivot to some of the best practices and the issues and challenges that the system presents here. So if we go to the next slide, thank you. I've kind of highlighted a few key ones here. And again, I'll have Ben Paul elaborate on these too, but in my travels, certainly one key thing is the relationship between plant engineering and facilities engineering. We see it, especially at larger sites, a lot of them have facilities teams that are kind of divided into two camps, right? There's the facilities engineers that execute projects, right? They're project managers, they execute the projects. And then there's the plant engineering team that is there to kind of keep the plant running. And it never ceases to amaze me how at a lot of places that there's not a lot of communication going on between those two groups. And then when you throw maintenance into the mix, you know, the maintenance team, you know, it can be challenging, right? It can be challenging if all three of those entities aren't on the same page. And you know, we talked earlier about how, you know, Ben Paul and his team is engaged in everything that goes on there at the site, whether it's new projects or you know, existing challenges with the plant as it stands. That's so key. Secondly, I highlighted the commissioning process, and again, we touched on a little bit before, you know, as part of that overall project process. Again, if there's not a, you know, the project team hands over a space, but the controls haven't been wrung out, it can lead to some real difficulties when the customer occupies that same space and the controls need to be sorted out by the plant engineering team. So some rigor in that handover process and commissioning is key. You know, the system itself, you want to make sure it's maintainable, and make sure that the team that's assigned to maintain the site itself can understand it too. There's been other challenges I've seen where you know, and I'm an engineer myself. Sometimes engineers can overdo it and make things so complicated that the maintenance teams have a hard time understanding, you know, what we're trying to accomplish. And again, if there's not a good handover, it makes it even worse. So you know, that's keeping an eye towards the end user is key as well. Obviously, energy savings, that's one of the, you know, the main reasons we're talking here. And then the you know, the fact that have that on-site capability in-house is really helpful. Again, I've seen other places where there's not a Ben Paul really, or a controls czar or a controls team, and thus a lot of that it results in high costs and maybe suboptimal controls installations. So anything you want to add to that, Ben Paul, in the slide as far as best practices go, that or others?
Well, I'll just bring out, you know, the working relationship with plant engineering. I mean, we have always worked hard to work with our maintenance group, and I spent my first few years out here working with them on a daily basis, and you know, established relationships with those guys, and this does two things. It leads to energy savings because they have ideas that they don't know how to get implemented, and I do. So a lot of times they would say, hey, you know, if you did this, you would save energy, or if you did this, I think this would help. And a lot of times I realized, no, well, they had a good idea, and I could even expand upon it for more. So I could turn their ideas into energy savings projects. And then a lot of times I couldn't implement anything right away, but later on I could implement it and gain that fruit from that idea. And then at the same time, I always try to bring solutions to their problems. They can call me anytime, day or night. Trust me, they do. And they may have a problem or not understand how a system works, and I will take the time to help them with their problem and explain to them how the system works. And that builds a relationship of friendship and trust that turns into energy savings and maintenance savings and makes things more reliable. So I feel sorry for plants that do not have a facilities group that works hand in hand with their maintenance group, because if it's not functional, it's dysfunctional.
Yeah. Thank you. Well said. All right, so if we go to the next slide, we're going to talk just a little bit about issues and challenges, right? And I think some of these bullets are ever challenging, right? I mean, updating master. You can imagine keeping on top of all the documentation, the drawings, the master drawings for a site as big as Fort Worth, or system as big as this is quite the challenge. The op tempo, right? The pressure. I mean, there's a real pressure to get the production floor humming, right? And push F-35s out the door. Training, certainly as the systems age too, that can be problematic. The one that we've got highlighted here, again, it comes down to manpower and people, right? And finding and keeping the key people is a challenge, and it seems like it's ever more a challenge as we move forward. And I'll say keep people certainly internally, like Ben Paul and his team. But I know I've also seen, some sites that maybe rely more on their vendor, and they're fortunate, and they have a good point of contact that handles their building management system. And then that person leaves, and then you've got somebody, who's doesn't have the same knowledge of the site, obviously, or maybe some of the same skills that are beneficial to the site. It can really throw a monkey wrench into things. And so I know, Ben Paul, I don't know if you want to talk for a second about your succession planning there. I know you've gotten a few folks under your wing, right? Rumor has it you're not going to be doing this for like the next 50 years. I mean, I don't know, I could be wrong, but
No more than 35.
okay.
No, it is very difficult to find personnel that want to do this, and when you find someone, you really have to make the job challenging, intriguing, and fun for them to want to stick with it and continue doing it. And it's kind of, I'll get back to this. We're like, my group is like a family, and we operated under the guidance that everything is relational before it's functional. And so we all have a very strong relationship. We're friends, and we want to improve this system, and then I want to be able to hand it off to highly qualified people that can continue on that tradition.
All right. So if we go to the next slide, I know we have just a few slides left and probably about 5 minutes of time here. So probably not going to take too long to talk about where we are today. I think we talked about how, hopefully you've gotten a sense for all that the system is used for above and beyond basic building management or energy management. As we talked about, compliance with ESH, requirements. See all the different things that the EMCS controls, as we talked about, gives you some sense for scale. You got over 30,000 tons of chiller plant under control. As we talked about manufacturing, all the lighting systems, paints, it's quite an impressive list. You got a little screenshot on the right there. I want to get to the next slide, because the next slide, if we could go to the next slide, really tells the the rest of the story, right? And about what results have come of this 40+ year focus on the energy management control system. And you could see, and I'll let Ben Paul talk for a minute or two about this, just how impressive these results are.
Well, as the system grows, we save more and more money. We use less energy. Just quick example. In 2007, our utility budget was 28 million. Last year it was 13, and I don't recall utility prices going down very much. So it's we've learned how to reduce consumption and how to minimize cost. That's what we do with the system, and we just keep expanding it and getting better at it.
And again, that's cost. Those are just utility costs we're talking about. Never mind the cost avoidance for projects where we didn't have to buy transformers or electrical gear or run new feeders and things like that that we talked about before. So yeah, that's quite an accomplishment, especially considering, as you can see, the aircraft, the F-35 production ramp up, which I think we're pretty close to full ramp up now, right? But it's quite a bit more than it was when it started 15 years ago. All right. So the next slide is I'm just gonna, again, I felt obligated to put a slide in here, recognizing our continuing relationship with Energy Star and the aerospace industry group. I mean, I'm really glad in my role over the last 5 years to have had the opportunity to meet all the fine folks in that group. I've learned a lot, and also I'm looking forward to seeing a lot of folks in person in a couple of weeks. As far as what we've done, and I say we, I mean they, at the Fort Worth team, there's just a few examples of the Energy Star recognition that's been achieved. And at the bottom there, we are actively looking at or pursuing the challenge for industry for that main F-35 manufacturing floor, which would be a nice feather in our cap here. So we're going to continue to work with Bruce and Danny and the team on that effort. Okay, so the last slide is just kind of a wrap up here. And again, it hopefully you've gotten a sense for what a really top of the line, robust energy management system can do for your site. I'm sure, I can't wait to see what other things that the team there uses it for. Although it's hard to imagine there's more out there, but I think they've got almost everything covered. Certainly you don't know what you don't know, and if you're not getting that data coming in through all those screens behind Ben Paul there, there's a lot of information that's just going to go by the wayside. And yeah, I don't know, Ben Paul, did you want to say anything else in conclusion? I meant to call out your quote at the beginning, and then I failed to do that. So let me get that out there too. You said the only effective method to eliminate wasted energy is by providing exactly what is required, when it is required, for only as long as it is required. So you want to talk about that or anything else as we wrap up?
Well, that's basically how we design things. All of our designs are set up such that that statement can be achieved. So we make sure the necessary sensors are installed so that we can prevent waste. I'll just leave it at that.
All right. Well, I think with that, we have about 10 minutes for questions.